This presentation is entitled Temporal-Based Transitive Closure Maintenance. It's an advanced feature. The notion of transitive closure is a clever way of doing graph navigation in a relational database management system. Now the thing about graphs is they potentially change over times. You may be adding or deleting nodes or connections. So one of the things you might want to do is, I want to know what the graph looked like on such and such a date in the past. So this feature allows you to ask historical questions using transitive closure of what a graph might have looked like in the past.
Temporal-based transitive closure maintenance. Information technology has a number of challenges associated with it. For today's presentation, we're going to look at two. We're going to look at something called fragility. In today's multi-tiered architecture, oftentimes you have the problem where one of the tiers has a change, and that change causes a ripple effect that breaks other layers. The second challenge is one of rigidity. It's the inability to easily modify data schemas on the fly. To address the challenges identified in the last slide, we're going to look at a technology called TCSQL. In particular, we're going to look at its ability to maintain transitive closure through time. So as nodes and connections are added or deleted in a graph, the transitive closure is maintained, keeping a record, a historical record of those changes. We're going to start by doing a little graph theory here. In front of us are two graphs, a family tree and a graph of bus routes. Some of the components of a graph consist of the following: the notion of something called nodes. In this family tree graph, the nodes happen to be the names of people here. A second component of graphs are these things called connections here, or edges. And they happen to be the arrows we see between nodes here. Sometimes in graphs, you have a semantic relationship associated with these arrows. In this family tree graph, we have a father of relationship, and we have a mother of relationship. Sometimes with graphs, you have scalar values associated with the connections. In this bus routes example, the scalar value represents a cost of going from one city to another. The notion of transitive closure is a concept that is foreign to most people. So let's look at a definition of transitive closure. Given a graph G, the transitive closure of a graph is the set of all potential paths between all nodes in the graph here. So in fact, the transitive closure of a graph can be represented using a relational table here. So the way to think of the population of this table, you can think of it as follows. Take any two nodes in the graph, let's say starting with N1 and looking at N6. Does there exist a path, directed path from N1 to N6? The answer is yes. Therefore, we see a transitive closure record here. Does there exist a directed path from N2 to N6? Notice I say the word directed, you got to follow the directions of the arrows. The answer is no. So N2, N6 does not show up here. So what can you do with the transitive closure of a graph? You can use it to navigate a graph. So if we want to know all of the descendants of N1, what we can do is write a select statement as follows. Select child from transitive closure where parent equal N1. Now let's play computer a second here and let's execute this query here. Let's find all the rows here where the parent has a value of N1. We see that in green here. And let's find all of the children from all those records. And what we find is we get N2, N3, N4, and 5, N6. So in fact, that represents all of the descendants of N1 here. Now, one of the unique things about transitive closure with respect to TCSQL features the ability to maintain transitive closure in a graph as a graph changes. So normally, if you're adding or deleting nodes or connections in the graph, what happens is you typically have to rederive the transitive closure from scratch. One of the features of TCSQL is its ability to maintain transitive closure whenever nodes or connections are added or deleted from a graph. So let's look at TCSQL's ability to historically maintain transitive closure over time. So imagine we have two graphs here and we created them on February 1st. And imagine that on February 5th, we disconnected C2 from C4, and imagine that on February 8th, we connected D3 to C4. And now let's say you want to ask a question of what the graph looked like on February 7th. Well, TCSQL provides the ability, in this case we're looking at a view definition, has the ability to ask such questions. So why is this valuable? Well, first of all, I just demonstrated the ability to ask what a graph looked like on any particular day. Secondly, with this capability, it eliminates the need to maintain multiple versions of underlying data.